If you're spending more time battling awkward tools than battling bugs, check out Seek. You can install it anywhere and get instant visibility in how your apps and services are behaving in production. Seek collects structured logs from Serilog, Microsoft Extensions logging, and other libraries, and presents them in a real-time web interface that's like a log file, but with superpowers. Learn more about Seek at datalust.co/SEQ. That's datalust.co/SEQ. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Rachel Lim. She's an engineer at OpenAI, formerly at Google and Dropbox, and a Stanford-educated engineer, and now a member of the technical staff. How are you?
I'm doing great. How are you?
I am excited to learn all about AI here because I hear so much about OpenAI and the great stuff that's happening with things like GPT-3 and large language models. And now I get to talk to you. And you've been at OpenAI now for over a year.
Yeah, I just hit my 1 year anniversary recently.
That's great. Were you always working on AI? I know AI. I know that was a thing that you were interested in school with a concentration on artificial intelligence. But I'm curious at your previous jobs if you worked on AI.
Yeah, so before this, I was at Google where I was working on TensorFlow, which is a machine learning library used widely by developers who are developing new machine learning models. So TensorFlow at the time that I joined was part of Google Brain. And so I was always kind of adjacent to research, though I've always been also in more of an engineering role myself. So not doing that much of the research, more understanding how to make models train quickly, how to make them run inference quickly, etc.
How much has AI changed since you learned about it in school? And it's only been like 5 or 10 years, and now it's like a whole other industry. Like, is it the things you learned still apply, or is it moving too fast?
I would say the things that I learned don't even really apply, though I think there's a whole wide range of things you could learn within AI in school. So there's like more traditional machine learning techniques, like those were all before the era of deep learning. So a lot more linear algebra, kernel methods, etc. And that was kind of what I learned in the like foundational machine learning class. Now in industry, at places like OpenAI, at places like Google Brain, I don't think these methods are as commonly used anymore. And a lot of people are about this technique called deep learning, right? So it's about bigger, deeper, like wider models that have just kind of proliferated in the last I don't know how long it's proliferated for actually, but it's now the like most popular thing.
Yeah. Everyone's talking about GPT. There's GPT-2 and GPT-3 now. This generative pre-trained transformer, these large language models, these deep neural networks. I don't think these existed really when you started in school, did they? This is like a thing that's exploded in the industry.
Yeah, I definitely did not hear about language models until basically the time I started working at Google.
hmm And what is the difference between like a basic language model and a large language model? Because like I've got a little TensorFlow running on a microprocessor and I can train it on me saying yes or no. Or I've got like my Alexa here that knows a couple of things that I can say. But behind it, there's a deep learning language model, but there's the local processing. Like when I say Alexa, it's listening for the word. Or if I
Mhm.
say yes or no, it can hear yes or no. That's a small local edge based model, right?
As you said, there's a size difference, right? So you have large language models that kind of run on these huge computers in the cloud somewhere. You have smaller models that can run on edge devices, like what is running in probably your phone, your Alexa device, and so on. One of the things about size for deep learning models in general is that we find that larger models tend to be more capable. So there's a whole theory around this called scaling laws, where they predict that as the size of a model increases, their capability kind of increases proportionately.
Mm. So when we think about this concept of a language model, I'm using the example of like consuming, like hearing voice and turning it into an abstract syntax tree. But GPT and AI language models like that provide a variety of language related tasks, right? And the thing that blows people's minds are the creation, the inception of language from nothing. That's very different than understanding language, right?
In a model like GPT, there isn't really an explicit abstract syntax tree at any point in the model, right? There might be one implicitly somewhere, kind of embedded within the weights and how they relate to each other, maybe. But when we say language model in machine learning now, we're really just talking about a model that will take in some sequence of text as input and predict what comes next. So it might not necessarily need to actually understand the structure of the tree to be able to predict what comes next. For example, you could just give it a string of gibberish and it can continue producing gibberish without actually having any structure for the gibberish that came before because it's gibberish.
That's interesting.
With the ability to predict what comes next, you can kind of coerce that into most tasks that people care about.
Okay, but let me ask you this, and this is just me trying to get my head around it. If I gave you as a human gibberish, at some point you would push back and you'd say, "This is gibberish you're giving me. Like, this is not really helpful. You're not moving things forward." But if I can give an AI model gibberish and it continues to produce gibberish, inferring a pattern, then how can I feel confident when I give it actually something useful that it's not going to also produce gibberish?
The AI does exactly what you just said, which is that it tries to infer a pattern and it tries to predict the next word that would be the most likely given what it has already seen. So if you give it something that kind of makes sense, it tries to follow the pattern and continue it. So, for example, if you were to give it the first half of a movie script, it will try to continue the script based on what it's seen before. If you give it a dialogue, if you give it the transcript of this podcast, it will try to predict what I am going to say next.
That would be really interesting.
And it does so just by kind of predicting what has the highest probability. I know, actually, one of the projects that I've thought about working on the side is just kind of fine tuning a model on a whole corpus of podcast recordings, of podcast transcripts, and seeing what clever new insight it can come up with.
So, like, not for nothing, just throwing it out there. We've done 826 episodes of the show, and I've got a corpus of over 400 hours, and I have transcripts of all of that. So you are more than welcome to see if you can let me take a break and produce the next 500 episodes of the show for me. That would be wonderful. Okay, so here's a question though. You said that it tries to predict the next word. And this is the thing that I'm having trouble getting my head around because using an analogy here that's like when you think about atoms, they're very small and molecules are made up of atoms. In language, we have syllables that turn into words and words into phrases and clauses and then suddenly a concepts. This AI is thinking about what the very next word is, but it can also hold a thought over multiple paragraphs and come up with cohesion that lasts pages. I'm having trouble understanding how we got from atoms to molecules to an elephant.
Yeah, word is not actually even the right word to use in this case. It was kind of a simplification I used, but actually, what the model does is that it predicts the next token. So, a token is sort of like a subword, is one way to think about it. So, it tends to be a little smaller than a word, but some words themselves are also tokens. So, it's just a tokenization scheme that we use to feed into the model. The interesting thing about tokens, as opposed to words, is that tokens let you express more than words, right? Because if you imagine your training data has some vocabulary of like maybe all the words in the English dictionary, and you wanted your model to be able to predict words that don't currently exist, you won't be able to compose them if you only have words. But if you have subwords that are tokens, you can compose these subwords together to kind of make new words that kind of seem like they make sense. Does that make sense?
I think so, but I'm still trying to apply it in the context of language from a human's perspective while you're helping me understand it from language from a computer's perspective. So when I think word or subword, I think about compound words and then I think about syllables. And then I'm also, for some reason, thinking about German, which the German language loves to take three or four words and then squish them together into one big long word. you know. But when I read text that has been generated by OpenAI, I don't see a lot of invented words. So maybe help me understand more what a token is in this context.
When you see text that is generated by OpenAI, it is true that in most of the examples that you've probably seen on Twitter or on the internet or on things that people have made into like actual production worthy apps, you're seeing real words because that is what people want the model to produce. I could imagine an app that I create where I tell GPT-3, here, invent new words for me. And then I give it a few examples. So, a fish that is wearing a hat, arrow sign, hatfish, or something. That's not a word that exists. And I just made it up. It's a terrible word, but maybe you can give it a few more examples in that vein that kind of make sense. And it can probably generate a new novel word that you haven't seen before.
Yeah, interesting. That does make me feel like German. Using German as an example, like the word for ambulance in German is Krankenwagen, sick wagon or sick car, right? So it's an invented word, but then it like, yeah, I could see you. That makes sense. I could go with that. So you could definitely do Dr. Seuss style text with OpenAI if you asked for it.
Exactly.
At the end of the day, your customer has to be at the center of everything you do. This starts with the right customer data strategy, as well as the right foundation to solve the challenges that typically inhibit the success of your company, such as data quality, data governance, and connectivity. mParticle is your real time customer data infrastructure that helps you accelerate your data strategy by cleansing, visualizing, and integrating your customer data from anywhere to anywhere. Ultimately, better data leads to better decisions, better customer experiences, and better outcomes. See why the best brands choose mParticle. Go to mparticle.com. That's mparticle.com. So GPT-3 is something that people like want access to. They want to be able to use it and figure out how they want to apply it to their systems. And I understand that OpenAI, the company that you work for, allows for the ability to make kind of use custom versions of it that are tailored for your application. So you're going to get more the data that you want out of it, and you're not going to worry about it inventing words about fishes and hats.
Yeah, so that's a good way of putting it. So on your first point, actually, we've now removed the wait list. So anyone who wants, well, you can apply for access to GPT-3 and you won't be put through a like multi-day process anymore, and it should be immediate if you have access to it.
Mm-hmm.
On the topic of custom models, that was actually one of the things I worked on in my time here, which is the fine-tuning API. So fine-tuning is basically a way of taking a model that has been pre-trained on some amount of data and training it further on a select set of data that kind of is more in the distribution of what you, the user, cares about. So, for example, the base GPT-3 model is kind of good at a lot of different things. It's good at summarization, it's good at text, it's good at chat messages, it's good at writing scripts. But if I wanted it specifically to write Shakespearean poetry in the style of, I don't know, like how my mom would say it, it either wouldn't be great at it or it wouldn't be very consistent at it because it has so many capabilities. Sometimes it's like, oh, but I want to tell you about this other thing that I actually know a lot about and I can write a lot of text about. Right. So by fine tuning it, you're kind of nudging it into the direction that you care about so that you get this tailored model based on your data set. And it tends to perform more reliably for your task specifically.
Interesting. Okay, so applying this again to how I'm thinking about things, and I realize it's not a direct parallel, but if I'm thinking about things in terms of voice recognition, again, you're talking about output of text, and I'm talking about input of voice. If I wanted a system to understand what I was saying, it's going to do a lot better if I give it a subset of the kind of topics that I'm going to ask, right? If I asked my phone or my Siri or my Alexa or my whatever some question that included a word that is rarely used, I'm going to probably not get very good response. But if I ask it to turn lights on and off, I would expect that to work 100% of the time because that's its primary task. So I'm limiting its scope. Is this kind of a delta model, like a patch that you're putting on top of the thing, or is it more of an allow list?
You can think of it as a patch because all the weights in the model will have shifted by some amount after you fine tune it, and that amount is, I guess, a delta relative to the original weights. I really like your example because one of the things I was thinking of recently was that it might be possible to fine tune GPT-3 on Singlish so that it's able to kind of generate more Singlish text rather than just pure English, right? Because a lot of our data that the original GPT-3 trained on was from the web, and most of it is in English, not a lot in other languages, et cetera, especially not Singlish, which you wouldn't see a lot of on the internet.
In Singlish for our friends who are listening. You're in Singapore right now, so that's a dialect of Singaporean English. Which brings me to another question. We have this large language model. This is an English language model. Is it North American English? Is it UK English? Is it generic world English?
I would say that the model reflects the data set it was trained with, which is a large subset of the internet. So it isn't specifically American English or British English. It's kind of everything it's seen. It's also seen German. It's also seen most common languages that web pages are in. It has probably seen more English than it has seen of any other language.
Hmm. But I could I ask it to generate French, or does that just not it's not even in the same sport?
You probably can actually. So if you gave it a few examples of like English to French, it will continue that pattern. If you started typing a
Mhm.
block of French that was the start of a news article, it knows that you've given it French and it will try to predict what is probable in the sequence, which will be French.
So, in the context of trying other languages, I could teach it different languages, different pidgins, different sub languages potentially, and set people up for success if they were using it from Singapore or if they were using it from Canada or from somewhere else, right?
I think so. I haven't really tried fine tuning it on a Singlish dataset because the first step is acquiring a Singlish dataset, which I don't have, though I guess I could go around recording everyone around me and creating a dataset from that.
Now, we recently had a couple of tweets where someone said, "Hey, that word is offensive in Australia," or "Hey, that word is offensive in the UK." And as we find our way moving around English, we'll accidentally say things that might be a funny expression in North American English, but might be offensive in New Zealand. What do you do about things like that? And the AI couldn't know those things, could it?
No, I don't think the AI has a conception of whether anything it says is offensive. And it is possible that our models will generate text that is offensive, not sensitive enough for a particular subject matter, not truthful, etc. And I think those are all things that could happen. Our researchers are working on a lot of techniques to quote unquote align models with human intentions better. So, what that means is to have models basically do what people want. We actually just published set of results today about alignment that have to do with this new series of models that we're releasing through the API as well, called the Instruct series. And what the Instruct series is models that respond to human instruction. So the base GPT-3 models follow patterns, right? You give it some text, it continues what comes next. One of the problems we had was that people came to this and expected that they would just be able to give it an instruction and the model would be able to know what to do. So an example of this is you go to the playground, which is where people play with GPT-3, you type in create a Shakespearean sonnet for me. Now, what can come next in the pattern for this? The next thing could be create a villanelle, then create a limerick. So that could also be a plausible pattern to GPT-3, right? Where the pattern is actually just different types of poetry. With the Instruct series, we're training specifically so that it follows the instruction that users give it at the start. So if you say create a Shakespearean sonnet, it is much more likely to actually give you a poem than to complete it with another seemingly plausible pattern if you treat it as just a pattern recognition device.
And I also understand that with these engines, these different features, you can put in labels and tags that tell you whether or not information might be potentially sensitive. So you could say, "This is an instruction. This is harmless, but this is potentially political." Like you don't know, but you could mark something as sensitive, right? And in doing that, fine tune it with a content filter.
Sort of. So we produce a content filter in-house that we make available to all of our users that they can
Okay.
run on the output of their generations. And that kind of tells you whether it's sensitive or not. In general, our users use that to decide whether or not they show results to their end users.
Oh, I see. So this is coming out. So the filter is detecting generated text and then marking it and then allowing the person who is consuming that text to make a judgment call on whether that is safe or unsafe or totally okay. And I understand that you err on the side of caution. So you're more likely to say that something is sensitive because you want to be extra sure to be careful there.
Exactly. It's not even necessarily that the model is saying something offensive. It might just be that the subject is kind of nuanced and hard to talk about. And we know that, it's likely to not treat the issue fairly. So we do err on the side of just being more cautious around that.
I really like that you point that out because that's the thing that comes down to it is the nuance, right? I've noticed that recently Twitter started putting things on tweets where they're like, topics in this area tend to be sensitive, like just be careful. Like you might be about to step on something because it's tweets are not nuanced. And, a phrase could be offensive to one person that isn't offensive to another, whether it be a cultural context or political or whatever. So it's cool that you're making sure that that is possible. So one of the things that people worry about with large language models is them kind of going rogue and saying wrong stuff, sensitive content, unsafe content. You have a whole section on the site called Safety Best Practices where you actually say, think like an adversary. This is in the documentation of OpenAI. How often was I give it instructions, do I have to worry about the output? Or do I really just focus on if I give it reasonable input, I'll get back reasonable output?
I do think that in general, if you give it reasonable input, you get back reasonable output. The guideline exists for several reasons. Sometimes people take what their end users give them directly and pass it into the input. And you can't necessarily trust what an end user gives you. Your end user might be an adversary in the security sense of adversary. It is also possible that sometimes models can go off the rails. We don't think this happens often, but it's not like a control system where you can say for sure the model 100% of the time will never do this one thing that we think is very terrible. We don't really have any like formal ways to guarantee that, but there are techniques that we can use to reduce the likelihood of that occurring. Where fine tuning is one such example, where you can kind of make it perform more reliably for the very specific task that you care about.
And that's really a great point because when we think about a large language model as like a storyteller, like I just start a random sentence and I get back some random data, that might be an interesting parlor trick and it might be great if we're generating fun stories. But we want to use these large modules for these large language models, rather for developers and for businesses to do interesting things. And this new customized feature that you're allowing can let you do things that are really domain specific, right? I could go and I tune this to the things I care about if I'm a lawyer or a doctor or whatever my sub language group is. What are some examples that you have been surprised by of people training in this new way and getting their expectations exceeded?
I think you make a good point that there's a whole world of difference between a like cool Twitter demo and a production worthy app that you can get customers to pay for. I think I've been super impressed by a lot of the things that we've seen from our users. Some of my favorites are we have this one of our users is a company called Keeper Tax, and they help contractors, freelancers do their taxes. So, one of the things that they do is that they take in people's financial statements and extract entities that can be used for tax filing purposes to see if they can automatically make any tax deductions for people. And they have been an early user of fine tuning from our alpha. So we've worked kind of closely with them to help them get good results, and they've kind of been giving us good feedback. And with fine tuning, they were able to increase the accuracy of their model by, I want to say, like, they said like 1% every time they added new data to it, such that it's now around like 90%.
Wow. So just by tuning it, just a little adjustment here and there, you're getting a percent every time you're thinking about that, and you get it up to a very reasonable success rate. That makes me wonder about all the different things I could use this for. I think one of the things that people initially struggle with is they see the cool Twitter demo, the cool, like, hey, look, I can make it say anything. It's a dungeon crawler. It just wrote a story from scratch, or, it wrote my blog post in the style of Lord of the Rings. But I could run it on the corpus of all of this podcast content that I have, and maybe you could write summary text because I could go and automate the description writing, which is the most difficult part of my job, is the afterwards writing the paragraph about what we talked about. I could do
Exactly.
that, and I could teach it. Since I'm a tech podcast, I could tune it to the topics and the things that I talk about here.
And the interesting thing is you already have all the data from before. So you have all your transcripts from before and you have all your descriptions from before. So you have all the training data that's needed to fine tune this model.
Okay, so then when I do a customized GPT-3 with OpenAI, I'm also getting, I understand, not just better outcomes where it's going to be more accurate, but the training speed is going to be faster. And am I going to pay less because I'm going to have lower computing costs, because I don't necessarily need all the English language that's ever been thought of. I really want to just focus on the tech space that I'm in.
So it does tend to be cheaper than using the base models for several reasons. One is that when you use the base models, you have to give it a few examples before it's able to follow the pattern. If you fine tune the model, it already kind of knows what you want because it's seen all your data from before. And so you can get away with giving it fewer examples or no examples at all before it's able to do your task. Because we charge at a pay as you go rate, so we charge for the number of tokens you give us as input and the number of tokens that you are trying to generate as output. The fewer tokens you're using, the cheaper it will be.
Mm. Well, it sounds like this is a great time for developers to get started playing with these large language models. And where can I learn more about the OpenAI API?
Well, you can go to openai.com/API, and that should have all the information you need to get started.
Yeah, you can go. There's like a whole section on key concepts and the introduction, but I was really impressed with the examples. It's a ton of like what's possible. You can convert movie titles into emoji and generate product names and make lists of science fiction books. There's dozens and dozens of great examples that you can play with. So go ahead and check that out at openai.com/API. I'll put that link in the show notes. And thank you so much, Rachel Lim, for chatting with me today.
Thank you.
This has been another episode of Hansel Minutes, and we'll see you again next week.